Imagine a world where trees defy the very laws of nature. They don't just tolerate salt water, they crave it. They don't simply stand on solid ground, they invent their own, creating entire continents of life from liquid mud. They breathe through intricate snorkels rising from the water and give birth to live, swimming seedlings. This isn't science fiction, this is the daily reality of the coastal mangrove forest. And by the end of this journey, you will see these tangled, submerged roots, not as a murky wasteland, but as the beating, pulsing heart of our planet's survival. I'm about to take you deep into the world of these extraordinary ecosystems, and what you're going to discover will fundamentally change how you view our coastlines. This is a story of resilience, engineering, and a silent global crisis happening right at the water's edge. So let's wade in. The first thing you need to understand is that a mangrove isn't just one kind of tree. It's a guild, a collective of over 70 different species from various plant families that have all arrived at the same brilliant, desperate solution to an impossible problem: how to live where no other tree can. The environment they conquer is arguably the most stressful on Earth for a plant. It's a brutal cocktail of oxygen-starved, waterlogged soil, salinity levels that would kill any terrestrial plant, scorching sun, and the constant physical pounding of tides and waves. To survive here, mangroves have evolved a toolkit of adaptations that seem ripped from the pages of a fantasy novel. Let's start with most famous, the roots. Those iconic arching prop roots you see in pictures aren't just for show. They are multifunctional masterpieces. Physically, they anchor the tree in the soft, unstable sediment, acting like a living tripod against storms and waves. But biologically, they are lifelines. The mud mangrove roots grow in is anaerobic, devoid of oxygen. Just like us, a tree's roots need to breathe. So mangroves have developed new metaphors: vertical snorkel-like structures that grow upward from the underground root system, protruding above the water, and mud, like thousands of tiny, breathing straws. These are dotted with lenticels, tiny pores that allow oxygen to diffuse into the inner root tissues when the tide is out. When the tide comes in and submerges them, they essentially hold their breath, relying on the oxygen stored in their spongy, air-filled tissues. But the salt challenge is even more profound. Seawater is a dehydrating agent. It pulls water out of living cells. So how do mangroves drink it? They are master desalinators. Some species, like the red mangroves with their prop roots, are ultra-efficient filters at the root level. Their root cells have special membranes that exclude over 90% of the salt in seawater as it enters. The little salt that does get through is shunted to old leaves that are destined to fall, carrying the salt away with them. Other species, like the white mangroves, secrete salt through special glands on their leaf surfaces. On a hot day, you can actually see the salt crystals glittering on their leaves, or even taste the salt if you touch one. Then there's the matter of reproduction. In a dynamic, tidal environment where a seedling that falls in the mud at low tide will be swept out to sea at high tide. Simply dropping a seed is a death sentence. So, mangroves practice vivipary. They don't produce dormant seeds. They give birth to live young. The seeds germinate while still attached to the parent tree, growing into propagules fully formed, photosynthetic seedlings that can be over a foot long. When mature, this heavy, spear-shaped seedling drops, ideally spearing into the mud below to take root immediately. If the tide is in, it floats horizontally, drifting with currents for months, sometimes over a year, remaining viable until its tip brushes a suitable muddy shore, where it then rights itself vertically and begins to grow. This is how mangroves colonize new coastlines, building land as they go. And that process of building land is where we begin to see their true global significance. That single mangrove seedling taking root sets off a chain of events that literally creates new geography. This is the second monumental chapter of our story, the mangrove as master architect. Each root, each fallen leaf, is a brick in the construction of a living fortress. As those complex root systems, the prop roots, the nunavora spread and tangle, they act as a massive, dense net. They are natural baffle, a speed bump for water. When a tidal current flows in, laden with suspended sediment, it hits its root wall and slows down dramatically. The water's energy dissipates, and the fine particles of silt and clay it was carrying can no longer stay suspended. They settle out, depositing themselves around the roots. Over days, months, and years, this accumulation raises the elevation of the seabed. What was once open water becomes a muddy flat, which then becomes land colonized by more mangroves. They are not just living on the coast, they are actively extending it seaward. This land building is a gift of immense value. First, it creates a buffer zone, a sacrificial barrier that absorbs the fury of the ocean. When a tropical cyclone or tsunami makes landfall, the first thing it encounters is not a village or a city, but miles of dense, rough mangrove forest. Studies in the wake of the 2004 Indian Ocean tsunami showed that areas behind healthy, wide mangrove belts suffered significantly less damage and far fewer fatalities. The mangrove roots break up the wave's energy, reducing its height and destructive power. They are a living, self-repairing coastal defense system, more effective and sustainable than any concrete seawall. But their architectural genius isn't just about stopping big waves. It's about managing the daily rhythm of the tides and creating a unique habitat in the process. The complex root matrix forms a labyrinthine nursery. For countless marine species, the submerged mangrove roots are the safest kindergarten in the ocean. The tight spaces protect juvenile fish, crabs, shrimp, and mollusks from larger predators that can't navigate the maze. The nutrient-rich detritus, the fallen leaves that are broken down by bacteria and fungi, creates a soup of organic matter, the foundation of a prolific food web. It's estimated that up to 80% of all commercially caught fish in the tropics, including species we find on our plates like snapper, grouper, and shrimp, spend a critical part of their life cycle in mangrove estuaries. The roots themselves are often coated with filter-feeding communities, oysters, barnacles, and sponges, which further clean the water. Above the waterline, the ecosystem is just as rich. The branches host specialized bird life like kingfishers, egrets, and the iconic mangrove pia. They are a critical stopover point for migratory birds on epic journeys. Monitor lizards, monkeys, and even apex predators like tigers and the Sundarbans of India and Bangladesh patrol these forests. This biodiversity hotspot, this architecturally complex world, exists because of the tree's ability to stabilize and build land. Yet, this entire meticulously engineered world stands on a biological knife edge, a delicate balance of salinity, tide, and sediment, and that balance is being violently disrupted. The architect is under siege, and the reasons are directly tied to human activity. The very coastlines they protect and enrich are now the frontiers of our expansion, and our actions are dismantling these fortresses brick by brick, root by root. We are converting them for short-term gain, oblivious to the long-term, catastrophic cost. The scale of the loss is not just worrying, it's an active, ongoing catastrophe for our global climate and coastal security. The assault on mangroves is a multi-front war, driven by some of the most powerful forces in the global economy. To understand the crisis, you have to follow the money in the plate. One of the primary drivers is aquaculture, specifically shrimp farming. Vast tracts of mangrove forest, particularly in Southeast Asia, Latin America, have been clear-cut, their roots dredged out to create shallow ponds for cultivating shrimp for export markets. The economics seem compelling on paper, a high-value product for wealthy nations. But the reality is an ecological and social disaster. These ponds are productive for only a few years before waste build up and disease force farmers to abandon them and clear more mangrove forest, leaving behind a toxic, barren landscape. The shrimp are often exported, leaving local communities with a polluted water source, and the loss of the fisheries the mangroves once supported. It's a brutal exchange of a diverse, sustainable, natural resource for a temporary, monoculture cash crop. The second major threat is coastal development urbanization. As populations swell and tourism booms, mangroves are viewed as wastelands, perfect for dumping, filling, and converting into real estate. They are cleared for hotels, resorts, ports, and palm oil plantations. The demand for lumber and charcoal also takes a heavy toll. Mangrove wood is dense and burns slowly, making it excellent charcoal, leading to unsustainable harvesting. But perhaps the most insidious threat is less direct: pollution and altered hydrology. Mangroves are natural water treatment plants, but they have a capacity limit. Runoff from agriculture, carrying pesticides and fertilizers, and from cities, carrying heavy metals and plastic, floods into these ecosystems, poisoning the sensitive root systems and the life they harbor. Furthermore, when we build dams upstream on rivers, we starve the coastal mangroves of the vital fresh water and silt they need. The sediment that would naturally replenish and build the mangrove mudflats gets trapped behind the dam. Meanwhile, the reduced freshwater flow allows seawater to penetrate further inland, increasing salinity to levels even mangroves can't handle. The result is dieback, where mangroves wither and die from the inland side. And hovering over all these direct threats is the overarching specter of climate change. Rising sea levels should, in theory, be an opportunity for mangroves to migrate inland, as they have done in past geological epochs. But now, their retreat is often blocked by human infrastructure, seawalls, roads, and cities. They are being squeezed between a rising ocean and a concrete wall with nowhere to go. More frequent and intense storms also physically damage these forests faster than they can recover. The loss statistics are staggering. We have already lost over a third of the world's mangrove forests in just the last 50 years. In some regions, the loss exceeds 80%. This isn't just the loss of a pretty tree, it's the dismantling of a critical life support system. And when this system fails, the consequences are immediate, severe, and expensive. The disappearance of the mangrove buffer leads directly to increased coastal erosion, the loss of property and farmland to the sea, and the heightened vulnerability of millions of people to storm surges and flooding. The collapse of the nursery function leads to the collapse of fisheries, destroying livelihoods and food security for countless coastal communities. But the impact of losing mangroves reaches far beyond the local coastline. It resonates globally, and the mechanism for this global impact is hidden in the very mud their roots hold together. That black, rich, smelly mud is one of the most powerful weapons we have in the fight against climate change, and we are throwing it away. Beneath the shallow, sun-dappled water, entangled in that web of roots, lies a secret so potent it's been dubbed blue carbon. This is the third, and perhaps most crucial layer of the mangrove story, their role as a global climate regulator. To understand blue carbon, you have to first understand the carbon cycle. Trees, through photosynthesis, absorb carbon dioxide from the atmosphere. They use the carbon to build their trunks, branches, and leaves. When a tree in a normal forest dies and decomposes, most of that carbon is released back into the atmosphere over time. Mangroves do this, but with a staggering, game-changing difference. Their superpower is not just in absorbing carbon, but in burying it for millennia. Here's how it works. Mangrove trees are incredibly productive, constantly dropping leaves, twigs, and propagules. In a terrestrial forest, this litter would decompose on dry land, releasing CO2. But in a mangrove, this organic matter falls into the waterlogged, oxygen-poor mud. In this anaerobic environment, decomposition happens incredibly slowly. Instead of breaking down completely, the organic material accumulates. Layer upon layer of this carbon-rich debris gets packed down by the sediment the roots trap. This process can build peat deposits that are meters deep and thousands of years old. The carbon is effectively locked away out of the atmospheric cycle. The numbers are mind-blowing. Pound for pound, hectare for hectare, mangrove forests sequester carbon at a rate up to 4 times that of tropical rainforests like the Amazon. They are among the most carbon-dense ecosystems on the planet. The majority of this carbon isn't stored in the living trees above the water. It's stored in that vast, deep reservoir of soil beneath them. This is what makes their destruction so catastrophic from a climate perspective. When you clear a mangrove forest for a shrimp pond, you do two things. First, you stop the future sequestration of carbon. The engine of burial is turned off. But far worse, you expose an ancient, buried carbon bank to oxygen. The mud is dug up, aerated, and begins to decompose rapidly, releasing centuries or millennia of stored carbon back into the atmosphere as carbon dioxide and, in some cases, the even more potent greenhouse gas, methane. It's like discovering a massive, hidden leak in the hull of our climate ship. The emissions from mangrove deforestation are disproportionate and devastating. While they account for only a small percentage of global deforestation by area, they contribute a significant percentage of the resulting emissions from all deforestation worldwide because of the immense carbon stocks in their soils. Protecting existing mangroves, therefore, isn't just about saving trees. It's about preventing a massive, uncontrolled release of greenhouse gases. It is one of the most cost-effective and immediately available natural climate solutions we have. But the narrative can't end with doom and gloom. Because while the threats are severe, the story of mangroves is inherently one of resilience and regeneration. And around the world, a movement is growing, not just to protect what's left, but to actively bring these ecosystems back from the brink. The good news is that mangroves can be restored. They are builders, and given a chance, they will rebuild. Successful restoration, however, is not as simple as just planting trees. The failures of well-intentioned, but poorly planned campaigns litter coastlines, lonely rows of dead mangrove saplings that didn't survive because the underlying hydrology was wrong. True restoration is about restoring the function, not just the form. It's about understanding the tidal patterns, the sediment flow, and the salinity. It's about engaging local communities who have the most to gain from a healthy mangrove forest. In places like the Philippines, where decades of destructive aquaculture had wiped out mangroves, communities are now removing abandoned shrimp ponds, breaching the dikes to restore natural tidal flow, and then planting the correct mangrove species in the right zones. The results are transformative. Within a few years, fish and crabs return, shorelines stabilize, and the protective buffer is reestablished. This isn't just ecology, it's empowerment, economics, and survival. The final chapter of our mangrove story is about connection and action. This isn't a remote issue happening to distant, tangled swamps. The health of these root-filled shores is inextricably linked to your life, no matter where you live. If you eat seafood, the shrimp or fish on your plate likely started its life in a mangrove nursery. The stability of global fisheries is propped up by these forests. If you are concerned about climate change, mangroves are a frontline natural solution, scrubbing carbon from the atmosphere with an efficiency our best technology can't match. If you live on or care about a coastline anywhere in the world, the loss of mangroves anywhere contributes to a more vulnerable planet, with higher sea levels and more intense storms. So, what can be done? The solutions exist, and they work. At the governmental and international level, it starts with strong, enforced legal protection for existing mangrove forests, creating and properly funding marine protected areas that include mangrove ecosystems is critical. We need to integrate the true value of mangroves, their storm protection value, their fishery support value, their carbon sequestration value into national economic planning. Policies that incentivize conservation over conversion, like blue carbon credits, are emerging as powerful tools. These credits allow corporations or countries to invest in mangrove protection and restoration to offset their own emissions, channeling funds to communities that are the guardians of these forests. But top-down policy isn't enough. The most powerful force for change is informed, grassroots action. This is where you come in. Your awareness is the first and most crucial step. You are now part of a small percentage of people who understand the full story of these ecosystems. Share this knowledge. Talk about mangroves. When you see them portrayed merely as bug-infested swamps in media, challenge that narrative. Support organizations, both international and hyperlocal, that are on the ground doing the hard work of conservation and science-based restoration. Be a conscious consumer. Ask questions about where your shrimp and seafood comes from. Opt for products that are certified as sustainable by reputable bodies, which often means they were sourced from areas that did not recently clear mangroves. If you travel to coastal areas, seek out responsible eco-tours that support mangrove conservation and educate visitors. Reduce your plastic use and chemical runoff from your own home. What goes down your drain can eventually reach these sensitive habitats. For the students, the researchers, the passionate among you, consider this a call to a fascinating field. Mangrove science is vast, spanning ecology, biology, climate science, sociology, and economics. We need more minds dedicated to understanding and protecting these systems. And finally, witness them. If you ever have the opportunity to visit a mangrove forest, take it. Kayak quietly through a mangrove tunnel. Look down into the water at the galaxy of life clinging to the roots. Look up at the birds nesting in the canopy. Listen to the pop and crackle of the mud as crabs scuttle and roots breathe. That direct experience creates a connection that data alone cannot. It fosters a sense of stewardship that is personal and powerful. We stand at a tipping point. We can continue on the path that has led to the loss of over a third of these life-giving forests. A path that leads to more eroded coasts, more devastated fisheries, a more unstable climate, and more vulnerable communities. Or we can choose a different path. We can choose to see the submerged roots, not as a tangled obstacle, but as the foundation of a living, breathing, protective shield for our planet. We can choose to be allies to these incredible ecosystems. The mangrove has done its part for millennia, building, protecting, and sustaining. It has built the land, nursed our fish, sheltered our shores, and locked away our carbon. Now, it's our turn. Our turn to protect the protector. Our turn to value what has been silently invaluable for so long. The script for the future of our coastlines is being written right now, in the mud and the roots and the water. It's a story of resilience, but that resilience needs our support. It's time we become part of the solution to ensure that these majestic, muddy forests continue to thrive, not just for their sake, but for the sake of every one of us and for the future of our warming world. The tide is coming in. What we do next will determine whether these roots continue to hold fast or are washed away for good.